All right, so welcome to the relations test. So this is, I approximated 70 minutes, so it's an hour and 10-minute test. And my hope is, okay, so I'm gonna put the link to the test, okay, below. And after you've watched all the relations videos and little short lectures on all the different topics, you can take this test. And once you take it, you can come back to this video and then check, how well you did, what your thought process was. You can certainly put comments if you like below, and I'll try to answer them as well. Okay, so there's about 12 different questions on this, and they can be approached in slightly different ways depending on the types of examples that you're going to be posing. So I'm going to walk you through this particular test and kind of let you know what you should be thinking about and what you should really know out of these relations. All right, so question number 1. So question number 1 states, state a hypothesis about the relationship between class attendance and final grades in grade 9 in the United States. Okay, so the key thing here is understanding what a hypothesis is. And that was one of the first introductory videos. And I will be putting up, a link right above to the entire playlist if you wanted to watch all the different topics on these particular relations. So a hypothesis, remember, it's basically a statement that we make which will be true or false, and it has to be verifiable in some way. And so you have to create an experiment, in order to verify that particular hypothesis. So in this case, if you're going to state a relationship between class attendance and final grades, sometimes what I would see students do is they would say that students that attend the classes the most have the highest marks. So that is not a hypothesis, because how do you define students who are attending the most, and students who are not attending as much, and how do you define highest grades? So in order to do this, we do have to be a little bit specific, and the key idea out of this question is to really see if students understand how to create a hypothesis so they can actually create experiments to verify that hypothesis. So I'm going to give you a hypothesis for this one that we can try to verify. Now, it says that this is for grade 9, okay? So now in grade 9, what I'm going to state is students who attended 90% or more of the classes, had 80% or more on their final grade. That is a hypothesis which is definitely verifiable. So the key components, so here let me write it out. So grade 9 students who attended, so I said 90% or more of classes. And I'm going to change the color here. Received 80% or more on their final grades. Now, we are talking about grade 9 students in the United States. All right. Now, why is this a verifiable hypothesis? Now, by the way, this is not the only one. There are infinitely many that you can create for this. So don't think that this is the only answer, because that's sometimes kind of a flaw when you work with these relations. It is not really just a one-way street in terms of answers. So you could word it differently. You can set it up differently. You can even put it in the comments if you like, down below, and then others can let you know, or I can take a look and see them as well and see if they are right or wrong. So for this one, and I would encourage you actually to try to do that as well, right? To try to create a hypothesis of your own, not just follow this one. So grade 9 students who attended, so So the key thing here is, okay, 90%, let me make this a little bigger. So 90% or more. That is verifiable, right? So by attendance sheets, okay, so in grade 9, you can check, okay, how many students have attended 90% or more of classes. That's verifiable. That's either true or false. Then the other thing is that they've received 80% or more, okay, on their final grade. That is also verifiable. So once a student finishes, you can check if they received 80% or more. So those are the key things that you should have within a hypothesis, that you should be able to make these hypotheses, okay, either true, okay, by some data, or false. So that is the ultimate key. All right, so that's question 1. And now we're going to build on that particular hypothesis. Now, state the opposite of the hypothesis. So this is a great question to ask, because then it really forces students to see if they understand their hypothesis or not. And why is this important? Because a hypothesis is either true or false. So when you state an opposite of a hypothesis, what you're really trying to state is, you're trying to state the hypothesis in such a way that what you had above originally would actually be false. So you're asking yourself, okay, so when is it false? All right. So the opposite of the hypothesis above, okay, we could literally rewrite this thing, and I will actually kind of highlight and take it here. So let me take that, copy it, bring it down. And now what we want is, we want the opposite of this. All right. So the opposite of this is basically grade 9 students who attended, okay, so 90% or more of classes, okay, didn't receive 80% or more on their final grades, okay? So instead of the word received, so in this case, because what we're trying to do is we're trying to verify this, so we're trying to see that, well, if they attended 90% or more of the classes, did they receive 80% or more of their final grades? So in this case, we could say, okay, of classes did not, okay, receive, and let me put some space in there. Okay, I'm gonna shift this out a little bit. Did not receive. So this would definitely make this original statement false, because if you have students who do attend 90% or more of the classes, but let's say receive the 60% or somewhere in the 70%, then right away this would be false. All right, so that's what you're trying to check. So that would be the opposite of the hypothesis, at least for the one that I have stated here. Yours could be different. Okay, so now next, how would you collect your data to prove the hypothesis? And it says by primary or secondary sources, explain. So how would we collect our data here, right? So how do we actually create some kind of an experiment and create this data so that we can verify our hypothesis? So now, primary or secondary sources. So you should remember, so from the videos, so the difference between primary and secondary sources. So primary is basically, since we are creating the hypothesis, so our team, so let's say me and whoever's working with me on this experiment, we would go out into the United States and try to collect all the data, right? So how would I collect all the data to prove the hypothesis? So I would have to say, all right, so is it going to be primary or is it going to be secondary sources? Secondary sources, I would have to actually get statistics that somebody else has done on grade 9 students in, let's say, a particular year, whatever, in 2018, and then see, okay, based on their attendance and then their grades, okay, to collect that. Now, how would I collect, okay, the data? I would say that for this one, we could try, okay, this would be quite a venture. I would say, all right, so let me collect the data, okay, and say that it would be primary sources, meaning my team is going to collect the data. All right. Now, if you've chose secondary data, then obviously your answer would have been a little bit different than what I will provide here in the explanation. So because we are working with the US, so the United States, okay, and so what we want is we want data from the US. We want data, which is from grade 9 students. And we can have data, let's say, for instance, from, okay, and we can pick a year, let's say 2019, just for sake of simplicity. It can be any year. All right, so in 2019, so these would be the information that I would need. Okay, so I would say, all right, I'm going to choose primary data, which basically means, okay, that my team will collect the data. And now, how would we do that? Because that's quite a task, right? So, and that will lead into the next set of questions, okay, that we would have. So if I'm going to explain is, okay, so in this particular question, how would you collect your data to prove the hypothesis? So I would say by primary sources, which is our team, okay, would collect the data, let's say by selecting a specified group of schools in the United States. Okay, so my team would basically go out and try to collect the data, okay, and by selecting specified groups of schools, so not, let's say, all the schools, but a group of schools in the United States, and then we would concentrate on grade 9. All right, so here that would be the key. So that's how you can say that you are collecting the data, okay, as a primary source. Question number 4. In your experiment, identify the population of interest. So this ties into the previous question. So you may remember, so population of interest. Population means every single, in this case, grade 9 student in the US. All right, so that is my population. So let's write that in. So my population in this case is every single grade 9 student. Now, above I said 2019 in the US. All right, so that's my population. And what I would need, because of the fact that I said they have to attend 90% or more, so here, who attended 90% or more classes. All right, so that's what I would have to say. That is my population, because my hypothesis said that it was 90% or more attendance, and then it would relate. So anybody who didn't attend 90% does not fit that particular hypothesis in the experiment. Now, explain what would have to be done to create a census. So now here is another keyword, so census. So basically, this means that it's an experiment which includes every single student, right, in 2019 in the US who attended 90% or more. That's what we would need in order to create that census. So that's what we would have to write here. So explain what would have to be done. We would have to literally, okay, go out to every single, okay, in this case, grade 9, okay, and find out, okay, the attendance records of all students in 2019 and then check, okay, for those students who had attendance of 90% or more. Now you can see how difficult these experiments start to become. So what you will find is when you're working with sampling and what you're working with graphs, the actual end products are the easiest things to do, right? To analyze them and so on. The hardest part is creating that experiment to make it work and then really see, okay, what has to be done. So in this one, you would have to put in, okay, what would have to be done is you would have to go and find the records of every single student in 2019 who had attendance of 90% or more. And that's what you would have to put, okay, is in your answer in here. So you have your population and then you have your explanation. Question number 5. Provide an example of simple, systematic, and stratified random sampling for your hypothesis. Great question, because it forces you to go back, okay, and think back of what is the difference between simple, random sampling, systematic, and stratified random sampling. So again, okay, so don't forget, if you have forgotten, you can watch the video on that, on the data sampling, okay, which I explain the difference between the three. So if I wanted to provide an example, so let's assume that we have the entire population of 90% or more attendance of students. So simple, what I could do, okay, is, okay, so number 1, I could simply take, okay, all those students, I can arrange them in alphabetical order, and then I can just, okay, at random, let's say I wanted to have, okay, so a sampling of, say, 5,000 students in total. So in those alphabetical order, I could let a computer, okay, generate numbers, okay, for me. And then since the students were labeled from 1 to how many of them there are in total, okay, I could pick, okay, the student that was in a particular spot. So for instance, I need 1,000 students. So I would at random pick 1,000 names out of that entire sample. And then the computer can pick that for me. All right, it's almost like picking out of the hat, okay, 1,000 students that I would need. That is simple random sampling. All right, it's at random and it's simple because of the fact that you're taking the entire thing and you're just picking them one at a time. Okay, there's no strategy to it. So that's simple. Systematic would be that you have a systematic way. And typically what that means is that you're going to be picking, okay, a student every so often. So for instance, we could pick the first student and then we're going to pick, let's say, every 100th student, okay, in that alphabetical list. That is a systematic way. So it would be first student, then 100 student later, it would be 101st student, okay? Then 201st student, 301st, 401st, okay? 501st. So we have a systematic way where we are basically taking these students, okay, from a list, okay? So this is the list, and then we are picking, okay? So we're gonna start with 1, okay, and then we go down the list and we pick 101st, okay, because we're picking every 100. All right, so as we keep going through the list, that would be a systematic way, one example of a systematic way. All right, now stratified means that you have grouped your students in some way. Now, in this case, there is a very nice way of grouping these students. So in the US, you can take all the states that you have. So you can pick all the different states, okay, in the US. And then what you can do at random, okay, in a proportional way, you can pick, okay, students from, let's say you wanted to pick 100 students from each state. Okay, so let's say you pick Florida, okay, then you pick the state itself, and then at random you would pick 100 students from that state. You go to a different state, okay, and you pick 100 students from that state. That is called stratified because you're grouping them, okay, together in some kind of a way. All right, so those would be 3 ways. So simple, systematic, and stratified. So stratified is you're grouping them in some way. Systematic is that there's a systematic way. So every so often that you have a system to take them out. And simple means that's the easiest one where you just pick them at random. All right. And they are sampling methods because we're not taking the entire population. Because you can imagine doing the entire population would be really difficult to do in this case. To take every student that was in grade 9 in 2019, that would be very, very hard. All right, even picking 100 from each state wouldn't be that easy either. Okay, so now next, question number 6. Provide an example of a non-random sampling method for your hypothesis. So here, this question is testing your understanding between random and non-random. So non-random is kind of a biased way of sampling here. So bias, so that was also discussed in one of the videos on relations. So here, for example, I've mentioned the groups, for instance, the stratified way, we could simply just take Florida. Right? Is that a pure representation of all the US? No. Right? So that would be a non-random, okay, sampling method where you basically take a state and then at random, you could, from that particular state, okay, even though you think you might be picking them at random from there, okay, you have just chosen one particular group. Okay, and it's not a representation of the entire population. So that would be non-random. Another way is you can just pick your favorite high school and then just take all the students from there and then grab those students that had 90% or more attendance. That would be, again, non-random because you're just focusing it on that school, not on the entire US population. All right, so that's question 6. Question 7. So question 7 states, so Tesla, the automotive energy company, which probably a lot of you now know, wants to find out how many people under the age of 25 are interested in purchasing an electric vehicle. What is the population in this case? Which sampling technique would be most appropriate for collecting your data? Explain. All right. Well, they didn't give us a lot of information. So what they did say is, okay, they're interested in how many people under the age of 25 are interested in purchasing an electric car. So basically, in this case, the population is of the entire world. Okay, it is all, in this case, humans, okay, under the age of 25. Okay, that would be our entire population. Now, how likely is that? Probably not very likely, but they can definitely come close because now with the internet, they can start populating these things all over the world. Okay, so which sampling technique would be most appropriate for collecting your data? I would probably say some form of stratified. So you're going to be grouping them together. So stratified. Okay, random sampling. Okay, so, and in terms of an explanation, so for instance, I'll give you an explanation. So I would have probably picked, let's say, based on each continent, right? So you can take all the continents, North America, you can take Europe, South America, and so on. And then, so that stratifies, it groups things together, and then you can proportionally choose X amount of kind of people that are under the age of 25 to find out if they would be interested in purchasing a vehicle or not. So stratified, I think, would probably work best. Now, you, of course, can justify simple or systematic some way, but that would be up to you. So I would say probably stratified, and that's how I would pick it. All right, so that is question 7. Question 8. What is an outlier data point. Create an example to illustrate an outlier in a scatter plot. All right, well, an outlier, okay, so outlier is a data point that does not seem to fit, okay, the scatter plot trend that has been provided. And an example of this, all right, and I do talk about outliers in the video so you can look at them. Okay, so here, so for an example, you would be doing this. So I'm gonna kind of pick a random one that comes into my mind. So let's say you have a basketball player practicing their foul shooting, all right? So 5 days of the week. So I'm gonna draw this out here. Okay, so 5 days of the week. So here we go. I'm gonna try to draw this. Okay, and let's say that basketball player has somewhere around 80%. All right, so this is 80%. Let's say this is 60%. Okay, 40%, and so on. And 100% would be right here. Okay, and then this would be, so day 1, day 2, day 3, day 4 of practice, day 5. I'm not going to make it more than that. So this is the percentage. This is the days, okay, in a row as they were practicing. And let's say that they are about, okay, that 80% approximately. So, you know, say the first day was somewhere here, second day was somewhere here. Okay, so third day was somewhere here, fourth day was somewhere here, and then fifth day was somewhere here. All right, so this, okay, would be considered an outlier because notice that your trend that you have, so if you draw a trend within here, so you'll notice that the trend was kind of a flat line around 80%. And then they had, I don't know, maybe they were sick or something happened, and so they had an outlier point, okay, in their data that they practiced. Now, typically outlier points just from 5 would be very difficult to tell because someone can say that, well, wait a minute, maybe, you know, they didn't know much about basketball and they kind of drew it like this, something like that. So typically what we need is, okay, we need quite a lot more data than just 5 points, and then we can kind of tell if it's an outlier point or not. But this definitely serves the purpose and would have answered this question. So again, outlier is a point which is outside of the trend, and it's not just outside of the trend by a little bit, it's outside of the trend quite dramatically to be a data point which is an outlier. Okay, so question number 9. Identify the dependent and independent variables. So this is great. So this now will kind of force you to think about what the differences are. So again, remember in terms of graphs or plots. So if we're drawing these, okay, and we have our axes, so you have your X and your Y. So your independent variable is always kind of on your X, and then your dependent variable is on your Y. So that was also discussed in the videos on relations. I encourage you to refresh yourself if you don't remember. So the first one says, is there a connection between tree heights and soil moisture levels? So for myself, I would say, all right, as I look at this, so soil moisture levels, all right, would be the independent variable, and then the tree height would be your dependent variable. So that would go on the Y. All right, so that would be part A. So we can separate those that way. Now for your second one, we have, does the weight of a car impact battery depletion levels? Let's say maybe because of energy storage, for example. So here I would say that the independent variable is weight, and then the dependent variable would be your kind of energy storage, okay, battery depletion levels. So that's what I would say there. For part C, okay, do temperature levels correlate to AC energy usage in the US? So here I would say the independent, okay, is your temperature levels, and then your dependent is your AC energy usage that you have. So that would answer those questions. All right, so that's question number 9. Now, next, question number 10. Draw a bar graph for the following data. Make sure it has a title labeled axes. So the data presents grade 9 average, okay, percent grade for students born in each month. So there you go. So right off the bat, this would be my title. All right, so I'm going to say that's my title, and you could have written that in. And then, so for your bar graph, so we're going to draw this out in here. So our dependent and independent. All right, so let's say, so January, February, just for the sake of ease here. So I'm going to say January, February. Okay, then March, April. Then it would be May, June. July, August. All right, September, October. And here I'm going to have to make this a little bit bigger. So I'm going to make it a little bit bigger. September, October, and then November, December. All right, so that would be my last one, but let me shift it out a little bit further just so that they're not cluttered in. All right, so now I have to label all of these. Okay, so these will be the months. So that's what I have there. And then, so here would be your grade. So that's now labeled, okay, so labeled axes. We put a title, okay, so I highlighted the title there. And now we can do a bar graph. So notice, so within here, so maybe what I can do, okay, because we're mostly from 67% and above. So, okay, just for the graphs, you may remember when you were watching the videos, you can do something like this, which basically cuts the information. So this was 0% in here, and then here it just says, okay, so I'll put 60% here. All right, and then we can kind of clunk them in. Okay, so this is from 60, okay, then it's, I'm gonna put 70% here, and then we'll put 80% here. All right, and now, so let me label them, and I'm gonna, this is the beauty, I guess, of having, okay, this tablet. So for this one, so January, February, 77%, and it's a bar graph. I'm gonna nicely swing it back here. All right, so that's, let's say 77%. Okay, then I'll change it the color. 72%, so here. All right, so that's around 72%. Then I can, okay, again, I'll change the color, 68%, so something like that, 68%, and then you can finish these off so you kind of know what to do here. So that would have been a nice bar graph for this example that they asked. All right, so that was question 10. Question 11. So for this one, so this is a big one. For the following table, so day versus price. So notice that's what we have there. Okay, so quite a lot of data there, okay, that we're dealing with. So it says interpolate the price on day 11 and day 21. So this is great. It forces us to recall what interpolation is. So on day 11, all right, so we have a missing piece. So that's right here. Okay, so this is missing there. And interpolation, so one way of doing that is taking the data before and after. So you have the two data points before and after, and then you can average them out. So for instance, in this case, I mean, if this was a test, you probably would have to show this. Okay, so this would have been, let's say A. So the interpolated point, so that's 18 plus 1720 divided by 2, which is the interpolation point, and we can plunk that into our calculator. All right, and sorry, divided by 2, so 17.6. So this would have been 17.6. So let's put that in there. 1760. And the other interpolation point is between day 20 and 22. And again, you could have just written that in for part A. So I'm going to do it all in one. So 23.05 plus 27.35 divided by 2. So 25.2. So that would have been this one. 25.2, I believe. Let's see here. Yep. Okay. So those would have been our 2 points that we had there. All right, so that was part A, and you could have done it that way. Draw a scatter plot for the data. So let me kind of remove this so we have a little bit of space here. So drawing a scatter plot, so this would have been a little bit annoying, but that's all right. Remember, you had 70 minutes here, and you're not really explaining it like I am. You just have to kind of do the whole thing. All right, so let me do that, and I'll kind of move this closer here. So we have our price, would have been our dependent variable, and day is our independent variable. And then we can mark them, so from day 1 all the way through. Okay, so we'll have day 1. Let me blow this up so that you can see it. Okay, so day 2, day 3, day 4, day 5, day 6, 7, 8, 9, okay, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Notice I'm running out of space here. So that would have been the challenge. Right? So I'm going to run the line all the way. Okay, so we have 20, I said 20, 21, 22, 23, 24. Okay, and then of course this could have continued on. Okay. And now putting the scatter plots in here. Okay, so I'm going to do a few of them for you. Okay, so we have so the following, and just to cut it short, okay, so I'll do it and then you'll notice that I'm going to kind of speed up the video in there, okay, so that you can see it. All right, so I'll be quiet and then you'll see kind of the end result. All right, so there we have it. Okay, so it kind of looks a little messy, but that's what scatter plots are. Okay, so in terms of mapping them out, you would kind of see something similar. Of course, on a test, you don't have to be perfect. I mean, it depends who your teacher would have been, but this is good enough in terms of a nice scatter plot for these. Okay, so that was our scatter plot data. Draw a line of best fit. Okay, so a line of best fit, well, this definitely looks like a weird line here. So it's going to be probably something like that. All right, in terms of best fit, probably something like this. Okay, now is your line linear or non-linear? Well, definitely non-linear. Okay, in this case, it's not a line. Okay, so that's the reason why. Okay, so that would have been answering part C. So this is a non-linear because it's not a straight line. Okay, extrapolate the price on day 30. So day 30, well, we were at 24 and 24 was around 32.55. So notice it looks like this thing's kind of blowing up on us here. So if we were continuing this on, right, so this is kind of going straight kind of upwards. Okay, and I don't know how it would have went, probably something like that. So day 30 would probably be somewhere in the 40s or 50 range. So in terms of approximation, so to extrapolate this, you know, I can say, all right, so let's say $50 based on this extrapolated amount. Okay, so that's what you could have answered for that. Now, what trend do you see in the price going in the future? So it looks like this thing is going to skyrocket straight up. Now, for F, if the actual price on day 30 was 31.8, well, so that changes things, because 31.8, it means it would have been dropped. Okay, then what does that tell you about extrapolating? And that's the point, you know, so students should know and understand that extrapolation is just that. It is actually just guessing based on the information you have. So both interpolation and extrapolation, if you're really missing those data pieces, you're just kind of guessing, right? You're approximating. And now notice I said around $50 range, because it would have been skyrocketing up, but it really was around $31, so it didn't happen at all. It kind of started going back down. And this is, by the way, if it's kind of like from the stock market, if you're looking, you know, this is what happens to people. They get so excited, oh my gosh, something's going up, and then they think it's going to, you know, skyrocket, and yet those are the moments when prices start to fall down. All right, so this was a fantastic question, and really asks you to see, do you understand scatter plots, you know, interpolation, extrapolation, do you know how to draw the lines of best fit? So this was a beautiful question. I hope that you tried it. And now for question 12, which is the last question, explain what is happening in each distance time graph. So what movement is in the graph, linear or non-linear, any outliers? So, well, in terms of outliers, what we could, you know, right away see, so we have an outlier here. This maybe looks like an outlier there. So you could have pointed that out, okay, in terms of writing it in the test. Are they linear or non-linear? Okay, so well, so for the first one, you know, this looks very much linear. Okay, so that's what happens there. So this one's very much linear. This one kind of looks, I mean, you know what? It could have been something like that. Or you could, okay, even draw it like this, straight down, across, okay, up, and then like this. So it could have been something like that. That would have worked as well in terms of your movements. So now the first one I would say, okay, so this one's definitely linear. Okay, this one, okay, depending on how you draw it, so this could be non-linear. Now these portions are linear, so this portion, if you would draw it like this, would be linear, and then this portion that you draw, right, that was linear. Let me draw it right in there, except different color. So this would have been linear because it's just a line, right? This is linear for that piece. And then finally, this is linear for this piece. So this is another great question. So again, it just depends on your interpretation. If you said this whole thing was non-linear because you drew your graph, you know, going like this, right? Except through the dots in terms of best fit, you would have said it's non-linear. This one right here, so definitely, so one linear piece, another linear piece, and another linear piece. So 3 linear pieces. This one is definitely non-linear, right? Because it's kind of blowing up on us. It looks like some kind of an exponential. So now it says in terms of movement. Okay, so what is the movement happening? So notice this is a distance versus time graph, right? So this is your distance, this is your time. So the movement in the first one, so it looks like we are kind of moving at a steady pace, okay? So we're getting further and further away in terms of distance, okay? So at a nice steady pace. In the second graph, so what we have there, so in terms of the movement there, let me kind of remove this thing. So in the first piece, so right here, so it looks like we are kind of coming down, right? So here our distance is, so we're kind of coming down, so at a steady pace. Then we're stuck at that distance. So here we're stuck at this distance right there. So this would be 1, kind of 2. Then we pick it up again. So then we go back and we're increasing our distance at a steady pace, and then we're stuck. Okay, again at some particular distance. So this would have been kind of 4 things that we could gauge out of this second graph in terms of movement. The third one, so this one just like kind of the second one. So this piece right here that we have, notice where the distance we're coming down. So the movement is kind of, we're slowly coming down, right? Okay, at a particular rate. So we're coming down, then we're stopped. So right, so this is, okay, we're stopped right here at that particular distance. So for this level, we're not moving anywhere. We're just stuck there, right? So that's the flat line. So whenever it's a flat line in terms of a distance time, so we're stuck. And then again, we start to move away, okay, in a constant rate. The last one, so this one right here, we basically are speeding up. Let me go back here. So we're kind of speeding up here in that direction, right? So we're very quickly picking up speed, so kind of slowly, and then wham, we're kind of going really quickly, okay, up. And notice our distance is really speeding up there. So that's what happens in terms of movement. Another great question in terms of trying to read the graphs. So now in terms of writing that out, it would have been quite a lot of fun for you. All right, okay, so this is a fantastic test. Okay, it covers a lot of things on relations that students should know. Scatter plots from bar graphs, hypothesis, population, primary, secondary data, these distance time graphs that you see here. That's an amazing, great test, so I encourage you to go through it and understand it. All right, so thank you for watching, and we'll see you in some of the future videos. Okay, cheers. Bye.